All right, this is test B. Find the measure of 65 degrees in terms of pi. So you just take, 65 and, oh my, what does it look like? Okay, find the measure of 65 degrees in terms of pi. You take 65 times pi over 180. And then reduce everything. 5 goes into both of those. Yep. 13 pi over 36. Find the degrees. The degree measure of negative 5 pi over 6. So if you want the degrees, negative 5 pi over 6 times 180 over pi. Pi's cancel out. 6 goes into 180 30 times. Negative 5 times 30 is negative 150. Very simple. All right. All right, you guys tell me. I don't know what the formulas are. What's the area of the shaded sector formula? That's if you have a triangle. That's not a right triangle. Okay, make sure you have your formula sheets up and running. So 1/2, the radius is 6, so 36 times theta is 30 degrees. You can barely see it on there. Can you guys see it on yours? Yeah. Or is it? Yeah, it's 30, isn't it? But it has to be in terms of pi, or in radian mode. So times it by pi over 180. Use your calculator and do the inside first. 30 times pi. Oops. Divide by 180. 0.52359. Multiply that by 36. And then divide that by 2. So square units. Any questions on that one? I'm not going to count it wrong because I don't want to count wrong for stuff like that. You should have that on there anyway. All right. Let's move this up. Number 4. Okay. Find the exact value in fraction form. So there's your triangle to the right. Sine of theta, if you look at this in SOHCAHTOA, that's what it's talking about. Sine is opposite over hypotenuse. Your theta, I didn't have it written on here. We're going to put theta at the top of the triangle. Okay, so now the sine of theta is your opposite leg over your hypotenuse, so that's 5/13. What's the cosine? 12/13. Cosine is the adjacent leg over the hypotenuse. And then tangent. Tangent is the opposite leg over the adjacent leg, 5/12. All right. Any questions on that? Okay. Find x and round to 4 decimal places. Okay, so I'm going to move this up. Find x. So we're given this corner. We have the opposite leg and the hypotenuse. So which trig function are we going to use? Sine, SOHCAHTOA. So we're going to do the sine of 75 degrees is equal to the opposite leg over hypotenuse. How do I solve that, people? Multiply by 12 to get it out of the denominator. So use your handy dandy calculator. Make sure you are in degree mode because you're dealing with degrees. 11.6, I'm sorry. You gotta go 4 decimal places. 11.5 5911. And I will count off if you do not round correctly. If I tell you to round to 4 decimal places, it better be rounded right. That's part of your math ability. Okay? All right, I need to make this just a little smaller. Let's move it up. Okay, a pilot's flying over a straight highway. He determines the angle of depression. So horizontal line going down. Horizontal line going down. Those are angles of depression. 5 miles apart. Angle of depression is 32 degrees and 48 degrees. What is the altitude of the plane? So we're wanting to know this right here. All right. So before we do that, do we have enough information? Not really. So that's what we're wanting to get to, but let's solve this triangle. Somebody tell me what this degree is. 100 degrees. Very good. 100 degrees. Sorry, you can barely see that. Do you know any of the other angles? Alternate interior angles, people? Thank you. So this is 32 degrees, alternate interior angles, and 48 degrees, alternate interior angles. Can't see that very well, can you? Huh. That's weird. Okay, and because of that, now we can get a whole bunch of different information. I can get little a and I can get little b. So we really only need one of these to solve this. So let's just solve for a. I'll show you why when we're done here. So what am I going to use if the law of sines to get a? Sine of 100 is to 5 as the sine of 32 is to a. Everybody solve for that, please. We're going to cross multiply. Let's see if you can do it right. If you don't get that, let me know. I'll write out the steps. Okay, so now that I have a, I can drop this altitude down. It's a right angle, and I use SOHCAHTOA. I can solve for, we'll call this, we'll call it y since it's vertical. So I can look at this and I can say I have 48 degrees, I have the opposite leg, and now I have the hypotenuse of that triangle. So I can use what to solve this? Sine. So the sine of 48 degrees is equal to the opposite leg over the hypotenuse. And again, we've rounded it. If you can use the full answer that you had before, you do that, but it's okay if you just use 2.7. So everybody solve that. Let's see if you can get that right. What'd you get?
2.
Yeah, 2 miles. So the altitude of the plane is 2 miles up. 10,000 feet. A little over 10,000 feet. Again, any of those story problems are possible. Not just this one. All right. Let's go to the next slide. Yeah, let's blow this puppy up. Okay, reference angles. The distance to your x-axis. So how close is 120 degrees to the x-axis? 60 degrees. Okay. What about negative 45 degrees? 45. Thank you, Chase. Remember, reference angles are always positive because it's distance. It's either in terms terms of degrees. If it's in terms of pi, you better give it to me in terms of pi. If you don't, I'm not giving you any credit. If it's in terms of radians without pi, then it better be in terms of radians without pi. All right, 3 pi over 4. Pi over 4, very good. And negative 2 pi over 3. Pi over 3. Think about where they're at. Now, you need to say so right now if you don't understand that. I'll draw it up on the board so you can get a visual. 9, 10, all right. Actually, I'll draw it up here if this is all right. So you have your circle, 3 pi. Where is 3 pi over 4? Where's 3 pi over 4? Yeah, so here's 1 pi over 4. There's 3 pi over 4. So this distance is pi over 4, isn't it? Okay, do you understand that? All right, look at this one. Negative 2 pi over 3, we're going this direction. So where is negative 2 pi over 3? You get 1 pi over 3 is 60. 2 pi over 3 is at 120. So negative 120. That's where we're at. Okay, so the question now is, what is this distance? Because that's the closest distance to the x-axis. So what is that? 60 degrees, which is, in terms of pi, pi over 3. Okay? We didn't talk about coterminal angles, so I'm going to do that right here. What's a coterminal angle to negative 2 pi over 3? Coterminal starts here and goes one or two directions. You can go this direction to get there, or it can go around 2 times the other direction. So what would that coterminal angle be? To negative 2 pi over 3. 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. That would be a coterminal angle in terms of pi. What's a coterminal angle to 120 degrees? There's 120 degrees. We would go this direction. What is that? Negative 240. This is 120. This is negative 240 to get to the same spot. Don't forget that stuff. I shouldn't have to reteach this to you guys. Come on. All right, let's go down to the next one. Give the coordinate in fraction form. Okay? Fraction form. So what is the x value at 5 pi over 6? Where are we? 5 pi over 6. Yeah, so the x is the long leg in that triangle. Negative square root of 3 over 2. All right, I draw a little bit bigger here. Sine of 120. There's 120 degrees. The sine is the y leg. So that's the short leg, and that's the long leg. So y is positive square root of 3 over 2. Okay, number 13. Pi over 2 is right there. What is the coordinate at pi over 2? 0, 1. So what's the tangent? Tangent's y over x. 1 over 0 is undefined. Do not put 1 over 0. I'm not going to give you credit for that. That doesn't tell me that you know what that means. All right. It's this one. Number 14. Name the quadrant. So this is kind of tough. Tangent is y over x, and it's negative. So either y is negative or x is negative. And then you look at cosine. It says the cosine is positive. If the cosine is positive, then that must mean the y is negative in order for tangent to be negative. So x is positive, y is negative. Where are we? Fourth quadrant, and you better write it like this. Good? Yeah, we're doing great. Make it a little bit smaller here for this one. Find the area of the triangle with side lengths 413 and an included side 64 degrees. Included angle, excuse me. What is the formula, please? Yeah, so everybody fill in what we have. All right, so that's 1/2 times 4 times 13 times the sine of 64. Everybody figure it out, see if you get the right answer. What? You're using radian. You're using degrees, so in degrees. 23.4. Oh, because I used sine of 65. It's my first mistake all year. All right, so let me put it in correctly this time. Yeah, 23.4. Okay, make sure you don't do what I do. But notice how different that was, all right? It is what it is. All right, let's do these. Let's blow this up. Exact value of pi. So inverses, remember that arc sine and arc sine and arc tangent only go to 0 to pi over 2 and 0 to negative pi over 2. So what is the pi value when y is the long leg? Square root of 3 over 2. Y is the long leg. And it's positive, so it must be up here. Pi over 3. Again, arc cosine goes from 0 to pi. And it's the x value. It is the long leg. It's positive. So long leg, short leg. What is that one? 5 over 6. Good job. Tangent. So tangent is y over x. Where are y and x the same thing? Because they have to be the same thing for it to be equal to 1, don't they? Yeah. And again, tangent goes from 0 to pi over 2 and 0 to negative pi over 2. It's positive 1, so it must be in the first quadrant. So it must be at pi over 4. You need to say something if you don't get what I just said. I know how to do this, okay? So I'm just going through the motions. If you don't understand something, say so. I won't make fun of you too much. Okay? Law of sines, all right? Let's shrink this a bit. So the law of sines, AB, we need little c is what it's asking. Oops. Little c is what it's asking for. All right, so how do we set it up? What's that? Sine of b over 80. Well, what is the sine of b? How'd you get it? Yeah, 180 minus 72 minus 21 is how much again? 87 degrees. And now we say the sine of 87 is to 80 as the sine of 21 is to little c. Everybody calculate that. And I'll try to hit the right buttons here. How do we do? I got it right. Woo! Is it this class I told you about taking yesterday, taking that test? Aiden, was that your class? Here we go. Law of cosines. So what are we finding? We're finding which letter? little a, which is x, right? So which formula we're going to use? The a squared formula. Everybody write it down. Don't forget your formula sheet tomorrow. How foolish that would be. Now plug everything in and solve it, please. Let's see if you can do it right. Am I done? I am done? Oh, what do I gotta do? Oh, yeah. 24.1. Yeah, hopefully you would look at that x and be like, how can that be 500 units long when all the other two legs are the way they are?